So we ended last time in part 1 with the calculation of the profits to men from having a competitive labor market for the labor of their wives, and the profits to men of having a collusive equilibrium where they acted as monopsonists, as the only hirers of their wife's labor. So now we want to know whether the profits from the competitive equilibrium for the individual man are greater than the profits for the monopolistic situation, or is it the reverse? Are the profits for the monopolistic situation greater than the profits in the competitive situation? Profits for the men are given by the difference between the production that they get, F of LD, and the wage that they have to pay, WLD. We're assuming that the price of the output here is just equal to 1, so we can ignore that. Now, the profits in the competitive situation are given by the quadratic production function minus the cost of labor, where we've substituted how much labor the men use, which is T plus LD, T plus LD, and where the amount of labor that they hire is determined by the competitive wage. And thus we have that. So now we'll go and substitute the competitive wage. The labor demand at the competitive wage is given by this. That was determined in part 1. Here's the labor demand at the competitive wage, and here's the labor demand at the competitive wage. So we substitute that in, we do some manipulation, and we get this expression for the profits. We can then go and find the profits in the competitive situation. This was the actually, I think this was the monopolistic situation. So we can then go ahead and get the profits in the competitive situation, and then we compare the difference in the profits between the monopsonistic situation and the competitive situation. For the profits in the other situation, consult the PDF file that is posted on the website. And we can then calculate that the difference in profits is equal to this, 3 over 144 times Km minus Kf squared, because it's a squared term and because capital, as we've noted, capital of men is greater than the capital of women. This term is positive, so monopsony is better for the men. So that's so far what we have. Monopsony is better for the men. But now, monopsony means that every man is abiding by a norm where they agree not to hire each other's wives. That way, the wives can only work for their husbands, and the husbands can say, here's a really low wage that's going to be better than your opportunity cost of working on your own field, which isn't very productive because you don't have a lot of capital. So you may as well come and work for me. Now, that equilibrium is a collusive equilibrium, and it has to be sustained by a kind of agreement that says we don't cheat on each other's. That's because there's a husband who might say, all the other wives are working at very low wages for their husbands. If I gave them a little bit above the wages that they get for their husbands, they'll all come and work for me. And they'll work on my fields, and I'll make a ton of profit this year. Remember, that's how profit works. You get a bunch of people to come and do work for you. Then you pay them a low wage, and then you get to sell the output of what they produce. So this cheater husband might say, I'm going to go around, hire all the women away. They'll come and work for me. I'll make a ton of money. Now, the collusive equilibrium it works the following way. When you collude, when you cheat on the collusion, the others then saw that you cheated, and so they refuse to abide by the norm, and then the world goes back to the competitive equilibrium. So for one period, 1 year, 1 season, you get to benefit if you're the cheater from cheating on this collusive equilibrium, but after that you're going to get the profits that you would get under the competitive situation. So we're going to find out first what are the profits from cheating. So when you cheat, you can hire n wives at the monopsony labor supply of the wives. So this is how many of the wives you'd hire. This is the labor supply at the monopsony wage. And we can quickly find that that's going to be equal to this, and thus quickly calculate the monopsony cheaters' profits, and we can determine that the profits from the monopsony cheaters are going to be positive. Of course, it's pretty obvious that if you cheat as on the monopsony of the others, you'll make better profits than you would have if you didn't cheat. So we have that situation, but remember what I was saying just a second ago. If you cheat in one period, you get these monopsony profits, but then every other period you get the competitive profits, pi c, and we'll discount those competitive profits by delta being delta less than 1, which means that $1 in the future is worth less today. So we might think that delta is equal to something like 0.9. So $1 next year is worth 90 cents today. $1 2 years from now is worth delta squared of that dollar. $1 3 years from now is worth delta cubed. So 0.9 times 0.9 times 0.9, which would be roughly 0.81 times 0.9, about 0.72. So $1 3 years from now is worth 72 cents today. So we now compare the profits from cheating. So if they abide by the norm, they get the monopsony profits plus the monopsony profits in the following year plus the discounted value of the monopsony profits in the second year plus the discounted monopsony profits in the third year. So what we need to do is think about the person abiding by the norm if the discounted value of their monopsony profits is greater than the discounted value of them cheating and then getting the competitive equilibrium profits. So we can simplify this because this is the delta pi m and the delta squared pi m is an infinite sum, right, goes on infinitely to the future, and a little bit of math will show you that that's equal to this, delta over 1 minus delta pi m. So it's a little math trick that's very useful. On the other side we have delta over 1 minus delta pi c, so this simplifies to a rather simple equation because we can do a little bit of algebra here, and that then turns out to be delta greater than 4/7, which, remember, delta is the discount factor. We earlier said it was like 0.9. So 0.9 obviously is greater than 4/7, and so in this simple model you'd have a presumption that the norm would be abided by. It pays to respect the norm because the discounted value of the profits of respecting the norm, of abiding by the norm, are greater than the discounted value of cheating on the norm. So therefore the norm is a Nash equilibrium. It's in each person's interest, if they think everybody else is abiding by the norm, for them too to abide by the norm rather than to cheat on the norm.